Hello everyone, welcome to MLAS 700, and we are going to be getting a start on the last set of labs for this course. We're going to start off with lab 17 this week, and then we're going to move on over to lab 18, and this is where we're going to do some machine learning. It'll be some basic machine learning, and we're going to go ahead and pull our Arduino out and get ourselves kind of rocking on this, and we're gonna get our Arduino IDE open up as well, and then from there we're gonna start writing some code. That at first what we're gonna do is we're gonna take this and get this LED strip up and running. So you're gonna go open your kit up. This is going to be a pretty straightforward one. We don't have a lot of bells and whistles on this one. It's just going to be this LED strip, and we're going to connect up the hot wire, the 5-volt ground, and then the signal, the yellow, and we'll go ahead and get that all going here in just a sec. So what we're going to do is first we're going to get this coded up so that we can read out the LED. So it's a visual voltage visualizer, so to speak. I wanted to keep it simple so that we read the voltage coming off of a pin on our Arduino, and then we take that and then we convert it to something that can be visualized on the LED strip. So let's go ahead and get that started, and the reason that we're going to do that is we're going to actually create a predictive model that's going to do some math in the next lab after this one, and then code that up and use this voltage visualizer, so to speak. It's something just kind of homegrown that we're cooking up, and then we're going to create a prediction on how many LEDs show up independently of what is actually happening. So one model will control, the control system is going to control the LEDs, and then we're going to create a linear regression model that predicts how many LEDs are going to show up. So it's a very, very clear case of machine learning, and it's something that we're going to just be using a little bit of math to do. It's a very basic model, but it'll be straightforward and hopefully a little bit of fun. Okay, so let's go ahead and get this started. All right, we're going to come over here. We're going to go ahead and do a new sketch. I'm going to say a new sketch, and on this one, we're going to what I want you to do before we even get going here, I want you to head on over to the library manager, and what you're gonna add in what's called the fast LED. So you'll type in fast LED. I've already installed it. It's just right here, multi-platform library for controlling dozens of different types of LEDs. So you're gonna go ahead and hit install. I'm not gonna, mine's already installed, but just hit just like this down here, just hit the install button. Let it run through, let it get installed, and then of course make sure you're working off of the Uno R4. Once that's installed, then you're good to go. We can go ahead and start to code. So once that's downloaded, and it'll show down on the bottom here, right in this area, that it's been installed, then you're ready to start coding. Okay, so first things, let's create. Let's go ahead and create a code block here. And explain what we're doing. So this code controls a chain of 8 NeoPixels, pixel LEDs using the fast LED library. Okay, and fast LED. Okay. And then what we're gonna do is let's just go ahead and go straight into our library. So we're gonna do include fast led.h, and then this is gonna be the LED library. And then we're going to to do, we're going to define, we're going to create some LED chain. We're going to define the number of LEDs, and in this case, when you look at this, it's going to have 8. So we're going to do define num LEDs 8, and that's going to be number of LEDs. And then we're going to define the data pin. In this case, it's going to be 6. Define data pin 6, and that's on our board. Number 6 is going to be over here. It's going to be actually printed on this side, and then we're just going to take the yellow wire here. We're going to connect up into pin 6, and that'll right there. That's what we're going to do. So we're going to come in from the top side and connect it in. Let's see. Oh yeah, and then we're going to define the voltage. In this case, the voltage pin. We're going to say define voltage pin A0, and then this is the analog pin to read onboard voltage. All right. And this is important because I do know that some of you are actually using voltage readings as part of your thesis research, and part of control, a microcontroller, and that's kind of leads into not only, of course, voltage, of course, is part of the equation of how much amps you can put and how much power you can put through a circuit. But that's also, on a broader scale for control systems rather, important for some of the research that I know that some of you are doing. Okay, so let's say data pin for LED control, and then that'll round that out. Okay, so that takes care of those. Now, excuse me, we'll set up a library here, the CRGB, not library, but variable. LEDs, and we're going to pass in the num LEDs from above into this, and then this is the array, actually, array to hold LED colors, color data. Alright, then in the void setup here, we're going to do the fast LED, fast LED dot add LEDs, and then we're gonna use the NeoPixel data pin, and then the arguments that we're passing is LEDs num LEDs. Okay, and that all looks good. And then this is going to initialize the, that's what this line of code does, initialize LEDs. Okay, then we're going to set up the communication, the serial communication for debugging. So that's the serial begin 9600, serial.begin 9600, the communication rate, this is start, serial comms for debug. Okay, and then we'll jump over to the loop, and on the loop, okay, so on the loop we're gonna read the onboard voltage level here, and so we're gonna do an int voltage value, and then we're gonna read the pin, and to do that we're gonna do the we're gonna pull a class to help pull that argument for the voltage pin in. So it's going to be analog read voltage pin, and then we're going to do float voltage and then that's going to be voltage value 1023.0, and we're going to do this this voltage value divided by 1023. We're going to multiply times 5, and this is a conversion that we're doing here to convert. This is to convert to voltage, assuming that 5 volts. Assuming that 5 volts is the reference point. Okay, so that works. Float voltage. Okay, so then what we're going to do next is map the voltage level to the number of LEDs. And this is going to be another int num LEDs to light, and equal to map, and this is going to be voltage value, so it's this one right here. Map voltage value 0, 1023, 0 num LEDs. Alright. Okay. Then we're gonna do a clear on the LEDs, clear all LEDs, and then that's just a an object fast LED clear for class level, and then we'll light the LEDs up. Light up the LEDs based on the voltage level. Okay. So this is going to be a for loop right here. So we're going to do a for int I equal to 0. I is less than num LEDs to light, and I plus plus. Let's go ahead and do the curly brace, and then we'll feed it the LEDs for I equal to that variable from earlier, CR red, green, blue. Let's see, and blue is the color we're gonna set. This is gonna set us up to run through it, and it will just gonna, in other words, we're just gonna do blue, and then set LEDs to blue, set LED to blue. Okay, now if you're interested in learning more about this for loop, we haven't talked about this a lot on right here, but it's these for loops, they're pretty standardized, like in terms of the way they're set up. So what you learn in computing principles from JavaScript is going to be the same, almost same construct. Same for Python. They're going to all have for loops are going to have. They're going to iterate using the same similar style. So if you're interested in learning more about that and need to freshen up, just jump on Wikipedia. There's some great stuff on there, and it'll get you just a high level. But in the interest of just kind of keeping this lab moving along pretty quick and condensed for what we need to do, because we got to get to another lab. Just go ahead and research that if you're unsure of what for loops do. But pretty straightforward. Okay, so fast LED dot show, and then we're gonna do update LEDs, and then we're gonna print the voltage to the serial monitor, and then we're gonna say serial dot print. And we're going to say voltage. Yep, and then that looks good. We're going to do a couple prints here. And this is just going to be print the actual voltage. That's the variable that we're passing into print to the serial monitor. and then we're gonna do another print. V LEDs lit. This is going to be important because this is actually, so what we're coding out is what the system is actually doing. So what we're doing here is we're creating some code that this is a finite state machine. So what we're doing is we're taking the voltage readings and then we're just repeatedly just showing what the voltage readings are. Now, they're going to change. Each time it comes out, there's going to be a slight difference in the voltage reading that's being read off the pin. But regardless, all we're doing is we're creating a machine that just that reads off the voltage. That's it. Because that's an important distinction to say, hey, this is a machine. And then what we're going to have is we're going to create a model in the second lab for this week, where we have something that observes it and predicts its outcome. So in this case, we're going to observe what the machine's doing, and then we're going to create an algorithm, in this case a linear regression, that predicts what it's going to see. So that's, or predicts what that should do. So that's probably the best way to say that. Okay, so V LEDs lit, and then we're going to do serial dot print ln, and then we're going to say num LEDs to light, and then we're going to put a delay in here. Wait before the next reading. So we're going to put a half-second delay. We're going to say delay 500 milliseconds, which is half a second, and that's it. That should just about cover what it is. So let's open this up just real quick here for a second, and then I'm gonna okay, so we've got our libraries. We've got our code block that describes what's going on, library that we're using, the fast LED, then we define kind of our parameters, and then our setup and our initialization, and then we get our loop, and this is the actual system that we're building here in the loop. So that's I think we're good. So I'm gonna go ahead and compile, and then see if this compiles. While that's compiling, hopefully that went okay and I didn't have any issues. We'll see if that went through without a problem. I'm gonna go ahead and get your Arduino connected up. I've got I've got USB-C to USB-C to my computer. You might have USB-C to USB-A, or regular USB. So I'm gonna remember yellow goes to pin 6. So I'm gonna connect up here to pin 6 right there. That's what I'm gonna connect to, and it looks like that went through without an issue, which is fantastic. Then on this side, I'm actually gonna connect up to the hot line. I'm gonna connect hot up to which is going to be 5 volts, and you're going to have a 5 volt right there, which is going to be that one, 5 volt, and then we're going to take our ground and connect that up right, and just like that. Okay, now what we're going to do is once that's going, I'm going to go ahead and upload this to our Arduino, and then get the sketch going, and that's doing what it's needing to do. Okay, and then all right, okay, so I've got as this is moving along, it's gonna bounce between 1 LED and 2 LEDs depending on the voltage that depending on the voltage that's running through this. So I'm gonna let this sit, and then maybe we'll see what it does here. So as this is running, let's go to our serial monitor now. And there we go. Okay. So that is doing what it's supposed to do. Okay. So sometimes it'll show 2, sometimes you see it'll bounce between 1 and 2 there. And that's, yeah, so okay, cool. So that's what we want. So now our machine right now is is working pretty good. Okay. All right. Now that's all we have for this one. This is good because this is a visual voltage visualizer. And essentially what this is going to do is it's staying at 1 LED for 1 volt, and then as it gets closer to 2, and in this case it seems like it's tripping over at 1.25 when the voltage goes up. Yeah, see, it hit 1.26. So there's a threshold that it's making up based on the algorithm, the math that we provided, which was at 1023 times 5, and that chunked it up according to the number of LEDs. So what it's going to do is, as the voltage goes up, it's going to give us a visual reference for that. So it'll go from 1 to 2 to 3 to 4 to 5 to 6, 7 to 8. So that's actually a really nice thing to do if you're ever looking for a quick, like a visual voltage regulator. This is a very good thing to have because then you can take this strip to the outside of the box that you have, or the gadget that you have, and this gives you a good visual reference to see, hey, everything's working okay from a voltage perspective. Now what we're going to do next is, that's the end of this lab. So we're coded up, we're ready to go to move on to the next lab. And on the next lab, what we're going to do is we're going to take our code. It's going to be we're going to sprinkle in a machine learning model that does a prediction and takes that prediction and moves it towards estimating what is going to show here. Independent of the system, we're going to say, hey, take the data that you're seeing and then do a linear regression on it and estimate, in other words, forecast what is going to happen, and essentially kind of like a predictive classifier. Are we getting 1 or 2 volts, and then predict whether we get 1 or 2 volts. So, okay. Now, I'm going to stop recording, and then we're going to go on, and I want you to head on over to the next lab.